This is the practice test for Chapter 4. I guess it would be called the 4A test because it's on sections 4.1, 4.2, 4.4, and 4.5. And we have factoring and solving by factoring today. And I want to make sure that everybody remembers that there's a difference. When we're factoring, we're just trying to find anything that we could pull out of this, and we want to go through the same steps every single time. We want to look for a greatest common monomial factor. If it's not there, then let's look for perfect squares. Is it a perfect square trinomial or a difference of two squares? And then if it's none of that, then it's good old-fashioned factoring time. But when we factor to solve, we have to keep going, and we have to actually find those zeros. So number 6 says x squared plus 4x minus 12. And the first thing I do is check to see, is there anything I could take out of all of those that would work nicely? And no, not going to happen. And next thing I do is look at the first and the last term to see if I'm dealing with a perfect square trinomial. Well, the x squared is a perfect square, but minus 12 is not a perfect square. So that brings me to good old-fashioned factoring. And I know that x times x is going to give me x squared. I need to find two numbers that multiply to negative 12 and add to 4. Now, most of the time, people will think of 3 and 4 right away when they're dealing with 12. So you have to be a little bit patient with yourself and realize, oh, this is 2 and 6, and the 2 would have to be negative in order to add to positive 4. And we know we're done factoring when there are no squareds left in anything, in any of the problem, in any of the parentheses, anywhere. So we've got that one totally factored. It is factored completely. Number 7, with that one, I would want to try to pull the 9 out, but I realize I can't do that because pulling that 9 out would give me fractions, and I'm supposed to deal with integers whenever I'm factoring. But then I think, you know what, maybe that's okay anyway, because the first term, 9x squared, is 3x squared, and the last term is 2 squared. So maybe this is a perfect square trinomial, and how I test it is by multiplying 3x times 2 and doubling that, multiplying it times 2. And if it equals 12x, then this is a perfect square trinomial. 3x times 2 is 6x, and 6x times 2 is 12x. This is a perfect square trinomial which factors as a binomial squared. And I know it has to be a 3x and a 2. And all I have to do to know whether or not there should be a plus or a minus in the middle is look between the first and second terms. That middle term is supposed to be negative, so that has to be the quantity 3x minus 2 squared. Now let's say you missed that, and you're over here and you're writing down 1 and 9, 9 and 1, 3 and 3, negative 1, negative 4, negative 2, negative 2, and you get done and you have 3x minus 2 times 3x minus 2. At that point, your light bulb needs to go on and you realize, oh, this was a perfect square trinomial and I missed it. And then erase all of this. You know, you already wasted enough time, so we want to make sure that you're using that time efficiently. Just write down that 3x minus 2 squared, because 3x minus 2 times the quantity 3x minus 2 is 3x minus 2 squared. Again, if you're always looking for the greatest common monomial factor first, then checking for perfect squares, and then going to good old-fashioned factoring, you'll be okay. And number 8, we cannot have a negative for the first term. So we're going to go ahead and factor out a negative 1, and that, of course, is going to change all of the signs that are behind it. And then what we do is think, well, a perfect square trinomial, x squared in the front is good, 72 in the back is not. So this might be some good old-fashioned factoring. And we're looking for two numbers that multiply to positive 72 and add to negative 17. And that would be negative 9 and negative 8. On number 9, we are definitely going to be looking for a greatest common monomial factor. There's negatives all over the place, so the negative needs to come out. All of those numbers are multiples of 5, so 5 can come out. And every single one of them has an x. So we're going to pull out a negative and a 5 and an x out of this. And because we took a negative out, all the signs will now be positive. We just have to be careful that we get our y's in the right place as we go through this. And you could always stop and distribute that and make sure you're going to get negative 5y squared minus 30xy minus 25x. And you do. Now, next thing we check for is perfect squares. I've got a y squared in the front. That is a perfect square. But the positive 5 in the back is not. So maybe we can do some good old-fashioned factoring on this one. Two numbers that multiply to 5 and add to 6. Well, that's 1 and 5. And there we have it. So again, greatest common monomial factor first, then check for perfect squares, then go to good old-fashioned factoring. For number 10, 16x squared minus 64. Today, several students said 4, take a 4 out of there, and I said bigger. And they said 8, and I said bigger. And they realized, 16 will come out of those. 16 goes into 64 4 times. And then we see, wait a second, it only has 2 terms. Oh, they're both perfect squares. So then I asked everybody, how do we make that happen? How do we make a first term a perfect square, a last term a perfect square, and not have a middle term? And they said x plus 2 and x minus 2. So that's our difference of 2 squares pattern. We have 2 perfect squares separated by a minus. Number 11, we would really like to be able to take that 4 out. Unfortunately, 7 divided by 4 and 15 divided by 4 are not nice things. So if we can't do that, we check for perfect squares. We've got a 4x squared in the front. That is a perfect square. We've got subtract 15 in the back. Not a perfect square. So 1 and 4, 4 and 1, 2 and 2 are the numbers that multiply to 4. And in the back, negative 15 would be negative 1 and positive 15, positive 1 and negative 15, negative 3 and positive 5, and positive 3 and negative 5. And we talked about how the people that wrote the book are the same people that write the tests. And so what they're often going to do is make it the bottom one, so we have to search for all of them. So we started checking outside times outside and inside times inside right there. And we had negative 10 plus 6, which is negative 4, and that didn't work. So then we went up to this one, and we said that would be negative 20 plus 3. Well, that's negative 17. That's not going to work. And we went here and saw, okay, that's going to be negative 5 plus 12. Oh, well, if I just switch the signs here, that'll be a 5 and a negative 12. So that was the one we needed, because outside times outside is 5, and inside times inside is negative 12. And again, these two numbers came from first times first, so x and 4x. And then these last two numbers, they had to be last times last, have to be in that order. Otherwise, we won't get the answer correct. And you can always FOIL any of these to make sure that you are getting the original trinomial back. So if we multiply this, we would get 4x squared minus 12x plus 5x, which is negative 7x, and then negative 3 times 5 is negative 15. So the top problems here, we're just dealing with factoring. You factor it, and you use the methods we've talked about. Greatest common monomial factor, then perfect squares. Do you have a perfect square trinomial or the difference of two squares? And then finally, we take a look and see, hey, do we have to do some good old-fashioned factoring? But now, new directions. Solve each quadratic equation by factoring. That means we have to keep going and we have to find the zeros. So number 12 says 9x squared minus 4 equals 0. And I think, can I pull the 9 out? And he can't. But maybe, just maybe, that's an okay thing, because these are both perfect squares here. And since we don't have a middle term, that's going to follow that difference of two squares pattern of 3x plus 2 and 3x minus 2. Now we don't stop. 3x plus 2 has to equal 0. So we would subtract 2 from both sides and divide by 3 and get negative 2/3. 3x minus 2 has to equal 0. So 3x equals 2 and x equals 2/3. Because our zero product property told us if our answer is 0, well then one of the things that we multiplied had to be 0. So that would be positive and negative 2/3. We go to 13. Oh, reminder, totally checkable. You need to put those numbers back in for x and make sure that you do get 0 when you put them in. Or you could put this into your graphing calculator and find the zeros, and it should say negative 0.666 repeating, and then positive 0.6 repeating. 13. Would love to take that 5 out of there, but I can't do it. It won't go nicely into 22 or 21. So that means I'm looking for perfect squares, and since 5 is not a perfect square, that's not a perfect square trinomial. So the next thing I would have to do is think, well, good old-fashioned factoring. 1 and a 5, 5 and a 1 will give me 5x squared in the front. In the back, I need it to multiply to positive 21 and add to negative 22. So that means I'm going to need a negative 1 and a negative 21, or a negative 3 and a negative 7, because they have to multiply to be positive, but add to a negative. And just like we talked about with the other one of these, you kind of want to think the bottom ones first. Well, if we do that here, we've got negative 35 and negative 3, which is negative 38. So that didn't work. Let's go up to this one. Negative 7 and negative 15. Negative 7 plus negative 15 is negative 22. So that is the combination that we want to use. And again, it's first and first, last and last. And here, if you can, just look at that and say, well, 3 minus 3 would be 0. You can do that. Otherwise, you could actually write out the math. X minus 3 equals 0, add 3 to both sides. This one we probably want to write out. So we'll add 7 to both sides and divide by 5. X equals 7/5. Again, checkable. Put them back in. Make sure you get a 0. Now, erase these and move this up so that we've got a little bit better angle here for the last two. Number 14, greatest common monomial factor. Nope, we don't have anything. Perfect square trinomial. Nope, there's a 32 in the back. So we're going to try some good old-fashioned factoring with this one. X times x gives us x squared. And then we just need to think of two numbers that multiply to 32 and add to negative 12. Negative 4 and negative 8. So x equals 4, x equals 8. There it is. There are our solutions. And again, if you need to, write this out and add the 4 to both sides and add the 8 to both sides. You'll get the same answer and check your answer. 15, I'm hoping to get the 9 out of there, but it's not going to work. So then I try perfect squares. Hey, this might be a perfect square trinomial because 3x, the quantity squared, is 9x squared, and 1 squared is 1. So if I multiply those two together and take them times 2, do I get 6x? 3x times 1 is 3x. 3x times 2 is 6x. It's working. That means this is 3x and 1 squared equals 0. And because we have subtraction between those first two terms, it has to be subtraction in the parentheses. And then 3x minus 1 has to equal 0. So we add 1 and we divide by 3. So x will equal 1/3. Now, why did this one just get one answer and all the others had two answers? Because if we graph it, what we're going to see is that this parabola hits the x-axis at 1/3 and bounces off. That's called a tangent. So it's tangent at that spot, and it gets to count for 2 zeros because of that little 2 right there. And that completes the practice test for the test of chapter